The third and final schema that you will use in the retail application is the user schema. This schema defines the data that you'll store about individual users. The user document will contain the user's username, their profile picture, their Facebook OAuth ID, and a list of products in their cart. The Facebook OAuth ID is the string that will serve as a unique identifier for this user's Facebook account. This will allow your users to log in with Facebook. User and product have a many-to-many relationship. A product can be in many carts, and a user can have multiple products in their cart. Users will typically have a small number of items in their cart, but hopefully your retail site will have millions of users buying millions of products, so a single product may be in thousands of carts at the same time. By the principle of least cardinality, as long as you assume that a user isn't likely to have more than 5 to 10 products in their cart, you can embed the list of product IDs in the cart subdocument. The user schema is pretty simple, but it introduces one key concept about MongoDB access control. In the product and category schemas, there was no sensitive information. You don't want to hide a product's price from any user. However, the user schema does have some sensitive information. In particular, you'd want to hide the user's cart because you don't want users to be able to see what other users are about to buy. You also want to hide the user's OAuth ID, which will link the user's account to their Facebook profile. Unlike SQL databases, MongoDB doesn't have any built-in notion of access control. That is, there's no way to tell MongoDB that only this user has access to these fields in this collection. However, the ability to nest documents in other documents provides your application an intuitive way to implement access control. MongoDB queries have a notion of a projection, which enables you to hide fields from the output of a query. So when you do find one without any parameters, you get back the whole document. But when you do find one with no criteria, but a projection that says to exclude the data subdocument, you get back a document that excludes this data subdocument. Thus, your application can use projections to make sure publicly facing code doesn't show a user's cart or OAuth ID. Conversely, there are some fields you want to prevent your user from editing. For instance, you never want your user to mistakenly edit their OAuth ID. That could break their login functionality. The preferred way to achieve this with the mean stack is also through subdocuments. For instance, suppose you had a function called modify user profile. Suppose this function, you only wanted to use it to modify the user's profile. It should not touch the user's OAuth ID or cart. You can achieve this by only assigning to the profile subdocument as shown. There is no way that the user can use this modify user profile function to modify the OAuth ID or the cart. However, if you were to add fields to the profile, say a job title field, then this modify user profile function wouldn't have to change.